Good morning friends. Today we are going to see the next part of the topic, that is an angular S.H.M and differential equation. Friends, I have already written the equation on the board. Here I have written the mathematical part. Remember, you have to add the theoretical part while making the notes. Friends, at the beginning of the topic we have seen the differential equation of S.H.M. What is that equation? d2x upon dt square, that is what is the differential equation. So d2x upon dt square plus omega square into x is equals to 0. So that is the differential equation we have studied. Now here also we have to write the differential equation for the toroidal S.H.M and as well as for the magnet which is placed in the uniform magnetic field. So here also we have to derive the differential equation. Friends, in this topic, whenever we are studying the differential equation at the beginning and at the end also, so but all these differential equations have the same format, that is they are in the second order of the derivative. Okay, so let us begin with the topic, that is the toroidal S.H.M. Now, what is meaning of the toroidal S.H.M? If you observe this diagram, here one thread is attached to the metallic disc, and when the metallic disc is rotated, then it will rotate in the clockwise and again anti-clockwise direction. So as it rotates in clockwise and anti-clockwise direction about its mean position, then naturally such kind of motion is called as the S.H.M. So what is the toroidal acceleration? If a metallic disc is attached at the end of the string and rotated in the clockwise and anti-clockwise direction, then such kind of motion is known as the toroidal S.H.M. Right? Now after this we will write the mathematical part. In order to revolve a body into the rotational motion, we have to apply the force, and when the force is applied, then torque is equal to minus c into theta. So this is the applied force formula. So torque is equal to minus c into theta. So where c is a constant. Now what does the negative sign indicate? That the applied force and the displacement, or the restoring force and the displacement, both are in the opposite direction. So here torque will act as a restoring force. So the restoring force and theta will act as a displacement. So that are in the opposite direction, or you can say the torque and the theta and the angular displacement both are in the opposite direction. So that's why we have applied the negative sign here. So torque is equal to minus c theta. But we know the standard equation for the torque acting on the body. It is the torque is equal to I alpha. Now from equation 1 and 2 we can write I alpha is equal to minus c theta. Friends, what is alpha? In the rotational dynamics we have studied that alpha is the angular acceleration, and angular acceleration of the formula d2 theta upon dt square. So we can write where I is for the moment of inertia, I d2 theta upon dt square is equal to minus c into theta. So d2 theta upon dt square is equal to divided with I minus c upon I into theta. So d2 theta upon dt square plus c upon I into theta is equal to 0. Below this you should write that this is the differential equation of a particle performing toroidal S.H.M. After this we have write the equation for the period of toroidal S.H.M. So normally the formula for the period is T is equal to 2 pi by omega. Now when we are studying the differential equation d2 theta upon dt square plus omega square to x, so friends remember this is omega. So omega, this is the d2 theta upon dt square plus omega square to x. So this is the value of the omega square. So what is value of omega? Under root c upon I. So under root c upon I. So t is equal to 2 pi upon omega, but omega is equal to under root c upon I. So t is equal to 2 pi under root I upon c, where I is the moment of inertia and c is a constant. So this is the equation for the period of toroidal S.H.M. Friends, in your textbook only the differential equation is given. For the period they have written the formula T is equal to 2 pi under root acceleration per unit displacement. So acceleration per unit displacement and then that acceleration per unit displacement can be modified or can be written in the same format. So the simpler way you can write T is equal to 2 pi by omega. You can remember, and you can take that this value is omega square. So because the differential equations have a standard formula d2 theta upon dt square plus omega square to x, and if we compare, this is value of omega square, so So based on that omega under root c upon I, so t is equal to 2 pi under root I by c. So this is the first equation regarding the torus and S.H.M. Friends, I am going to repeat this equation once again. So remember, while writing the equation, first we have to describe the diagram. So what does the diagram say? That in given diagram, it is observed that a metallic disc is attached to the string, and the metallic disc is rotated. Then the metallic disc will perform the clockwise and the anti-clockwise motion about its mean position, and so it is known as a torus S.H.M. Now the torque acting on the particle is torque is equal to minus c into theta. The negative sign indicates that the torque and the angular displacement both are in the opposite direction. But the standard formula for the torque acting on the body in the S.H.M is torque is equal to I alpha. So compare this. I alpha is equal to minus c theta. So if we are comparing, we are getting I is equal to I as it is. Remember, alpha is the angular acceleration. So angular acceleration is the d2 theta upon dt square is equal to minus c theta. The minus will become plus. Before that we have divided with the I. So d2 theta upon dt square is equal to minus c upon I into theta. So d2 theta upon dt square plus c upon I into theta is equal to 0. So below this you should write the sentence that this is the differential equation of S.H.M. Then you should write the equation for the period of torus and S.H.M is t is equal to 2 pi under root c upon I. Therefore t is equal to 2 pi under root I upon c. So this is the torus and S.H.M differential equation and the period. During the examination, the question may be asked for the 2 marks. Obtain the differential equation of torus and S.H.M. Then you should write up to this. And if the question is asked obtain the equation for the period, then and then only you have to write this part. Otherwise, not necessary. So based on the given question, you should write the answer. Now, once you got the idea how to write the equation, in the similar manner, we are going to write the next equation. It's the equation for magnet vibrating in uniform magnetic field. Friends, here one bar magnet is placed in uniform magnetic field, and you will observe that on the bar magnet there are two poles, north pole and the south pole, right? So when we are saying about the bar vibrating in the uniform magnetic field, in order to vibrate the magnet, there is a requirement of the force. When the force will act, at that time the magnet will be got deflected. Friends, remember the torque acting on the magnet have the formula torque is equal to minus mu b sin theta. Friends, you should remember this formula, and then it will be the very easier for us to write the equation. Torque is equal to minus mu b sin theta, where mu is equal to magnetic dipole moment. Now sin theta is very small, so sin theta is approximately is equal to theta. So we can write here torque is equal to minus mu b theta, equation number 1. But torque have the formula torque is equal to I alpha. We have already seen in this equation. Same thing we have to repeat here, but torque is equal to I alpha. So from equation 1 and 2, I alpha is equal to minus mu b theta. Now what is I? I is moment of inertia. What is alpha? Alpha is the angular velocity. So angular velocity here alpha is angular acceleration. So angular acceleration of the formula d2 theta upon dt square. So we can write I d2 theta upon dt square is equal to minus mu b theta. Now divide with the I. So d2 theta upon dt square is equal to minus mu b upon I into theta. Again this minus will become plus, then it will become on the LHS. So d2 theta upon dt square plus mu b upon I into theta is equal to 0. So below this you have to write the sentence that this is the differential equation of the magnet vibrating in uniform magnetic field. Friends, after this you have to repeat the same sentence that the equation for the period. So generally when we are writing the equation for the period, what is the formula for the period? That the t is equal to 2 pi upon omega. And what is the value of omega? So here if you compare here, so d2 theta upon dt square plus omega square into x, that is the standard equation. So omega square have value mu b upon I. So value of omega is under root mu b upon I. So you can observe that under root mu b upon I. So alpha upon theta, what does it indicate? That the period t is equals to 2 pi under root acceleration per unit displacement will be here, that formula. And as I have told you that here I am going to substitute the value of omega. So omega is equals to under root mu b upon I. So t is equals to 2 pi under root I upon mu b, where I is the moment of inertia, mu is a magnetic dipole moment, and capital B is the magnetic equation, magnetic induction. So friends, this is the equation for the period of a particle or period of magnet vibrating in uniform magnetic field. Friends, here also based on the question may be asked obtain the differential equation of a magnet vibrating in the uniform magnetic field. Then you have to write the differential equation. If it is asked regarding the period, then you have to repeat this part. So here friends, for the MCQ type of the question may be asked for the CET, JEE and the NEET examination, that which one of the following is the correct relation regarding with the alpha upon theta for a magnet vibrating in a uniform magnetic field. And the different equations are given: mu b upon I upon mu b, I square upon mu b, and I cube upon mu b. So friends, if you compare here, you can get the alpha upon theta is equals to mu b upon I. What is alpha upon theta? That the angular acceleration per unit displacement is equals to mu b upon I. So both are equation in the similar manner, only the symbols are the different. Once you get how to write the first equation in the similar manner, you can write. So friends, today we have seen the two important equations, that the toroidal S.H.M and the magnet vibrating in the uniform magnetic field. Friends, remember, as these equations are based on the diagram, so first you should understand or you should describe what you have drawn in the diagram, and then you should try to write the mathematical part. So I hope you have understood this part. Make the note properly, and friends, once you have made the notes, then try to write it once again without observing. So without looking in the notes, try to write the answers. So if you do the lots of practice, then your confidence will increase and you will get the clear idea regarding this point. So I hope you have understood this point. Thank you. Have a nice day.